It really comes down to considering the entire life cycle of the product, what it's going to be used for.
Volumes. That's pretty much the first thing we ask them, right? If you don't know your volumes and you don't know your price point, then you're kind of in a wasteland. To be able to have good and fast and low cost, you probably have to have experience.
Because you're always balancing all three, right? To some degree.
Yeah, exactly. That's what the engineering triangles.
Yeah.
Hi everyone, welcome to our new podcast, The Engineering Triangle. Today we're talking about design for manufacture. How can we be good, fast and cost effective? I'm your host Ayrton Sue here at Element Engineering Australia. I'm here with Daniel Berti, our Senior Mechanical Engineer. Dan has 12 years experience in mechanical DFM across a wide range of products. Thanks for coming on.
No worries, glad to be here.
This little 3D printed thing is pretty cool.
Yeah,
the Engineering Triangle, good, fast and how much it costs.
We've kind of hit all those with this one, I think. I mean, it's... looks pretty good. It's come off the thread.
So Nicole did that in Blender and then put it on the 3D printer. Was this one?
Yeah, and then she's touched it up.
Yeah, so we could
she did it on the SLA.
Very nice. So to start off, what's your favourite product that's been very well designed for manufacture?
Broadly speaking, I feel like as simple as it is, IKEA furniture is a big one. Yes, it's only mechanical, but all the thought is going into like making sure that thing can be built cost effectively at huge scale. And it can be used and set up and installed by anyone in the world, basically.
Yeah, well, IKEA's insane, the scale that they're at. But in particular for IKEA, they've got some specific manufacturing processes that they have to be able to pump out furniture at that scale. So the designs that they're doing are actually specific to the manufacturing processes that they've got in-house. So obviously you've got melamine or laminated chipboard furniture, things like that. Have to be able to put things together with very minimal tools, the tools that come in the box, effectively. And some of those fasteners and things like that are made specifically so you don't have to have special tools and things like that. So designing the furniture around the manufacturing processes that enable them to have massive scale.
Yeah, and obviously that was always from the get-go, they would have had the intent of we're selling at huge volumes because even to make the processes work, to do it the way they do, bring the costs down, they have to have the eye on the volume. So like it's something you got to consider from the start.
In that case, you can think about anything that's kind of mass produced.
It is.
With regards to mass production. So, being very boring, but Apple products are produced in the tens of millions per model year. I think the newest iPhone's got a titanium machined shell, CNC machined titanium billets that then get cored out and be tiny little thicknesses. That's kind of different because they've kind of gone for really high-end, elegant materials, but they've created the manufacturing process that gives them the advantage that they want. The advantage is like, a beautiful product that's made as lightweight as possible because it could be anodized aluminium, it could be steel, it could be plastic. You know what I mean? It might not have the feel that they want.
So obviously like they can charge premium because it's Apple. That's just what their customer base is. They're going for people that want high quality, well tested, well thought out products. The Lego was another one I thought. More just so because of the scale of it. Yes, it's very simple, but they do it better than anyone else. At scale. Like anyone that's played with Lego knows the kind of how well they fit together.
Tolerances on those things is insane. They're one of the biggest companies or best companies in the world that does injection molding. So they have to understand their manufacturing process intimately and then basically design their products around it. Like my kids have got all the different versions, the little dollhouse things and whatever, and they're not just the regular Lego bricks anymore. They're like all different shapes and to be able to get that whatever it is dollhouse thing or a little car or Mr. Whip Your Van sort of thing. They've made some very special Lego bricks that have to be specifically designed around basically the injection molding process. Obviously, they do an amazing job of it.
Yeah, I think I saw there was the tolerance on their mold is 0.02 millimeters, and then 8 out of every million parts get thrown in the bin. Whoa, that's their QA. Yeah.
8 out of a million.
8 out of a million is their rejection rate. So it just goes like they've got it nailed down.
I'd love to work for Lego.
So yes, it's simple, but it's not so simple.
Yeah. There's lots of other ones as well. Obviously car manufacturing, when you're manufacturing 1 million vehicles of the same model, it's just insane. The amount of different manufacturing processes that go into a vehicle, into a car, plastic injection molding with 2 meter wide bumpers is a monster job. Just going from a design that someone's thought up in their head, going through the process in interfacing with engineers or CAD designers or whatever, being able to actually then create things that are manufacturable within tolerance. Yes, it's insane what they do. And there's hundreds of thousands of individual parts, if not, high hundreds of thousands of parts in a single car that we all take for granted, and we go down and buy a cheap one for 20, 30,000 bucks. It's insane the amount of effort and quality that's put into these things.
Yeah.
How about the worst case scenario? A terrible design that should have never gone ahead into manufacturing.
Two things just jumped to me. And it was really the Samsung Galaxy Fold, the Fold that they released a few years ago.
Oh, yes.
And I think it was the Galaxy Note. I'm a Samsung owner, so.
Yeah, you've always been a Samsung guy.
But it kind of just goes to show like how difficult, in a sense, it can be to scale and do things right. I think it's important to understand, like, designing something for manufacturing to sell to the world.
So what was the problem with it? The problem was the actual screen itself.
So I think
right?
the screen, I think they hadn't properly tested the actual, and they ended up getting creases, and they were failing. With that Fold one that came out 4 or 5 years ago.
I think that's a classic case of, this would be a really awesome product, because as an idea, something that can fold down and be the phone size in your pocket and then open up and then be a tablet size, to be able to do more work on effectively, or
dual purpose
better
kind
interface.
Of thing.
But the technology really isn't or wasn't there at the time. The crease would drive me insane. I've never used one, but I've seen people using them, and I think it would drive me insane.
Funny enough, it was the first thing that came to mind when they came. I was like, that just seems odd. But anyway, they've got there now.
Most products that you interface with day to day are not great products. I mean, one thing that really annoys me, which is really weird, but is 3 litre milk cartons. They serve the purpose of putting in like 3 litres of milk into a single carton that's made out of PET, I think it is, like recycled PET, very, very thin, minimum amount of plastic in that thing. It could be recycled, all that type of stuff. But man, you can never pour the first cup of tea
without spilling
it down. That thing should be redesigned. That thing needs to be totally redesigned. And then the kids can't use it either, because the kids, the thing is 3 litres.
It's the most awkward thing. What annoys me is when some of them now, I'm used to them having the seal, but if you buy it from like IGA, for example, doesn't have the seal. So in my fridge, if I put something we go through a lot of milk, so I'll have like 2 to 3 litres at any one time. One's always sitting like lying down, but if we buy the brand without the seal,
everywhere, it's stinking. It's a terrible
so
design.
I've worked it out now. It's a 3 and a 2, fits perfectly in my door, in the side door of the fridge.
But I think it's one of those things where the design or the economies of scale have compromised on the milks, right? You go to America and they're like gallon, they're 3.8, whatever it is, 4 litres. Like there's, you always see in the movies and stuff, people trying to pour them or whatever, but it's the economies of scale, and obviously people want to buy that thing, and the downside to it is that you can't pour it.
Yeah,
well,
you can't deal with it. You want
deal with the spill, or you get really good at it, unlike us. Most things are pretty average. Everything pretty much has an issue.
There's always
some
flaws,
sort of issue
right?
to it. Yeah.
It's a trade-off cost, but you always have to understand, I guess, when you're going through the motions or the process of designing something, like who are you doing it for?
Yeah. But that's a lesson learned that we've learned along the way, especially with startups or new customers that we have come in the door. You don't have to have a perfect product, because how many products do you use every single day that you go, wow, this is phenomenal? You know what I mean? So design for manufacture is basically trying to get this thing to the vision that you've got, and it doesn't have to be perfect. What do you think is the key to really good design for manufacture?
So personally, I think it really comes down to considering the entire life cycle of the product. You basically have to understand what it has to achieve.
Yeah.
You need to really understand who it's being sold to, what it's going to be used for, how it might be abused, how easy does it need to be, how serviceable or whatever does it need to be for the user. You need to understand, volume effects, the cost and the processes at play.
Yeah.
Obviously manufacturing methods are critical, but depending on how many you're going to sell is going to change the approach that you take when you're doing that. People
understanding that it's not only design for manufacturers, designing for the complete product life cycle is
just designing.
Super important, because a lot of people don't understand. You've got to, first of all, manufacture the thing. So you've got to make the piece parts in whatever manufacturing process they've got. They've got to be assemblable. They've got to usually, if they're smart product, they've got to be calibrated or programmed. Then they go into a storage phase or like a shipping phase. That product's got to survive that shipping phase. Then there's an installation phase. Then there's an operation phase. Then there's servicing. Then there's disposal. So most people think about designing a product mainly just for the use phase. Most people will then consider what manufacturing processes they've got, but they kind of miss out those other pieces in the middle.
Yeah.
And we've seen that a lot. Transport and storage, that seems pretty simple, but if you've got an IoT device with a battery, and that battery, you have to have a special state for it. That device might sit on someone's shelf for a year, 18 months. How is its battery usage or its state going to affect either the user experience? Do you have to do something special when you get that thing out of the box, or do you just pick it up and shake it and it still has the remaining life inside that first battery that you would expect from the product? A really big one, especially that we have to talk about with our clients when we meet new clients, is volumes. That's pretty much the first thing we ask them, right?
Yeah.
It's like, what's your price point for the end user, and what's the volume that you expect to sell this thing at? The price point could actually dictate the manufacturing process you need. So say it's this thing's got to be cheap IoT device. It's got to be plastic injection molded a lot of the time. Maybe it's a premium product and it can be CNC machined, anodized aluminium or something like that. And you can have line up a factory through Alibaba within minutes, if you know what I mean. But the process of actually undertaking that manufacturing process with them is a long process. So you have to create supplier relations, and depending on what that supplier is capable of and how skilled they are, or the communications, you may actually choose a different process depending on your supplier. So one of the reasons why we've taken a lot of manufacturing processes in-house here at Element, as Dan knows, is just because we wanted to get closer to the manufacturing processes that we were using all the time: machining, anodizing, plastic injection molding, which we're getting into, but the liquid silicon rubber injection molding process that we used, that was a pain in the ass, absolute pain in the ass to deal with only a couple of factories in the world. The costs that were going to be associated with making, one batch of seals was the equivalent of what we would buy one machine for. So us being an engineering consultancy where we're designing things day in, day out, we want to do our design better. We want to get closer to the manufacturing processes, so let's bring them in-house. And
part availability, even like things. I know with electronics is a huge issue, like making sure you're future-proofed if parts become obsolete is a massive one that it's probably often overlooked.
Yep.
We've been there.
Yeah, COVID was horrible for that. Electronics components just being not available. Within a week, within a couple of weeks, having to redesign customers' products and saying, really sorry about that, but we have to eliminate that subsystem because of one chip that's not available anymore, and swap something out. But it is what it is. You have to do it.
Yeah, it happens a lot. So even on the mechanical side, we have it all the time. Like you go to the supplier websites or steel suppliers or whatever, and they'll list every single structural section possible, but most of them you'll find are not readily available. Like so we have our suppliers that we're kind of close to or embedded with. For us, it's a case of like we know what we can and can't get now. Yeah. We've kind of built that up over time.
Does that come down to relationships?
I think it's just working with them because they're all different as well. We found that, to be honest, most suppliers, things happen, mistakes happen, various occasions with things being done wrong. As long as they can address the issue, then these things happen.
And they work together.
But like availability is a massive one, especially when you want to do things quickly. It's all good again designing something. If you haven't considered that, or if you've just used a brochure and just gone, cool, I'm using that size. Sent it to the client and they've gone, oh, what the hell, I can't get this part. That's obviously not good for us.
Manufacturability is a team effort. I can't believe I've lost my cup, my Mount Rushmore cup. I've lost it.
I've lost many containers. I think someone put a post yesterday about the container. Oh. I didn't. It was actually my container, but it was not my food in there.
Oh, someone stole.
But it's like whatever. It's this thing. Like everyone's got the same container. IKEA and Woolly. Like where else do you go?
The sagas that happen. I was like,
whatever. I'll get another one.
Someone's gonna get smacked down.
Don't want a mouldy container.
That's the worst thing. Someone steals your container and then they leave it in there with mouldy food, so you have to clean it out.
I was like, I kind of wanted, and I was like, I reckon people knew that was my container. I think your mum would know. She's like, this is definitely Dan, but it's definitely not my food.
How do you quickly make something manufacturable?
Good one.
Oh, you don't.
You don't, yeah. Obviously, it depends what you're doing. I think obviously prototyping is a very different thing to also doing like, doing production runs or something. But I think even then when you're designing something, you can optimize the time it takes to put something together and sell it, obviously just through, trying to reduce effort, customizing things where you don't need to. Again, obviously tick the vision for whatever it is you're designing, right? Leveraging off-shelf parts and components where you can. Make sure you kind of do that sooner rather than later so you don't get stung. Probably just simplifying the design of whatever it is you're doing where possible. I know this is kind of an approach that we take tactfully when we're trying to vet something or prototype and test something. The intent is to always try and do it fast and as cost effectively as possible, because you don't want to go waste big bucks doing something that doesn't work or doesn't perform its function. This is where things like 3D printers, if you're just trying to get a feel for how something might feel or whatever before you go down the next route of say machining, and definitely injection molding is obviously a bigger step again. But I think there's things you can do like that to speed things up.
If you want a high volume product at the end of the day, you're going to use injection molding if it's plastic. But you can definitely use 3D printing to start with. And that could get a prototype out quickly that could be close in look and feel, basically, for what the customer wants. You can also, knowing these unusual processes in the middle, like vacuum casting, where you can go and make 20 of them, much more economically cost effective than, say, 3D printing. But be very, very close in touch and feel and end life performance to injection molding. So, again, knowing those manufacturing processes, I guess, is a big one.
We've been burned before. I think a tricky one is when you're, offshoring things, especially even for prototyping, right? You're talking, we've done it in the past where we've had things machined through, suppliers that we're relatively close to. But again, when you're going offshore, there's things you can't control. There's language barriers, communication, things like that. These are all things that kind of, they inevitably help if you can improve things on your end, whether it be drawings to communicate or be very explicit with your QA or finish or tolerances, things like that. So I think there's things that we've learned along the way, like you want to convey as much information as possible. Understanding the processes that you're using to get things made obviously helps, because I think this is where experience comes in, right? An experienced designer might, particularly if they don't have that knowledge in-house, they might do up a drawing or a machining drawing or something. They send it off to the supplier or machinist down the road. They don't care what the spec says, or you know what I mean?
But there's two outcomes there. They either give you back a really expensive quote and something that takes longer to manufacture because you put in the wrong radius or whatever for machining, or they give you back something that is different to what you asked for. Because they go, well, that's a 2 mil radius that could actually be a 4 mil. Well, I'm going to do it with a 6 mil milling cutter, so I don't have to do 2 extra passes or whatever. Having good relationships with your supplier as well is probably a massive, big one.
Big one.
Being able to just get on the phone or walk in the door and share a design with them, and then designing something with them along the way.
100%. Another one is probably, I think, would be QA. It's easy to buy all these things, get it all together, maybe assemble it, do testing, only to realise that your seal doesn't work because it wasn't machined right, whatever. When we do things now, again, through learning, we always make sure that the critical things are checked, because especially if you're relying on an external party or whatever, you want to kind of stop it before you get too far.
How about cost reduction? How does that figure into DFM?
Sorry?
Cost reduction, If you're designing for manufacture, it's horses for courses, So if you don't know your volumes and you don't know your price point, then you're kind of in a wasteland.
In a short, you'd probably say, right, you don't want to implement more complexity than is needed for that thing to do its function.
Absolutely, yeah.
What? Don't put 0.01 mil tolerances on something if it doesn't need it.
Absolutely.
Again, your machinist is probably not going to tell you. I'll just give you a high cost. You go,
Exactly, yeah. Most suppliers will get around something. They'll find creative ways to do it. That's their job. But that's how they get paid at the end of the day. But if there's an easier way, then it's going to be cheaper, and it's going to be faster as well.
We've done that with a few of our suppliers, even just one of our projects, like the glass, the
Yep.
capsules, for example, and the sapphire that we're using
Yep.
for our lens. One of the critical aspects of this lens arrangement we've got for
Oil and gas product
that we're working on. The sealing arrangement is critical in achieving a Class 600 rating. So I think the initial quote and specification we got for obtaining that sapphire was basically would work for a Class 150, but we had to bump that up to a Class 600, and even then, so they worked well with us. They're like, oh, no problem, we can implement this extra QA process for you. We can give you a bit of a certificate if you like, just showing the checks. And again, they can't make 100% of them to that spec, but we use the ones that are within spec. And then that's obviously costed in as a requirement anyway.
Yeah, some of the higher volume products that I've done in regards to cost reduction, SRAM Tyre Whiz, we decreased the cost of goods significantly by actually eliminating some of the subsystems that were in there before. We used the internal sort of analog sensor rather than having an external analog sensor. That external analog sensor during COVID was actually end of life anyway, or just not available during COVID. And we had to put more engineering effort in up front to do that, but it resulted in a overall cost reduction for the project and for the product as a whole, because the volumes were so high. The non-recoverable engineering costs, NRE costs, even though they were more upfront, they were less over the whole life of the product. So that was something that we scoped out pretty early, and we had to scope it out as a desktop study. And we sort of said, well, this is an extra effort that we're going to have to put in up front, but this will change the cost of goods. Bill of material costs will come down, the cost of goods will come down, and over the volume that we're going to look at.
So it's basically like a continuous improvement kind of thing.
Pretty much, yeah.
Yeah, because things happen, right? You might design something and then again, you haven't gone to the nth degree to bring the cost down.
Yeah.
You want to get something out and start making some money on it, right?
Yeah, exactly.
But then later you go, okay, cool, I can spend this extra time to refine the design, and we can get rid of that process, get rid of it.
In regards to design for manufacture with that one for Tyre Whiz, I guess it eliminated a few components on the board. The board could be effectively a bit smaller, which it was kind of set in stone, or the size was sort of set anyway. But less components on the board means better manufacturability. If you're only going to sell 10 of them, NRE cost is very high. If you're going to sell 10,000 of them, NRE cost is a lot less. You're going to sell 100,000, it's a lot less again. So I think I read somewhere that Apple apparently has a almost infinite budget for R&D, because the NRE cost, non-recurring engineering cost on any R&D is amortized across so many products.
It becomes negligible. It must be pretty close to it.
Very negligible, yeah.
It would make sense.
Yeah, so I don't know if it's true, but probably some
ridiculous number anyway.
Yeah. It's an interesting one. I think you can engineer around it. Yeah, but you have to take it into account and you have to amortize it. Yeah. You got to sell products. Everyone's got to sell a product. You can't be R&Ding forever.
Yeah.
You know what I mean?
Yeah.
So
you got to call it a day at some point.
We designed and manufacture Koodaideri's HydraTune system for technicians to remotely perform maintenance on dangerous hydraulics out in the field. We CNC machine, anodize and assemble the satellite pod and battery charger modules right here in our workshop. That's an interesting one. That's one of our larger full end-to-end projects, which is very enjoyable for everyone, and we hope they're very, very successful. They've got products out there in the field now being tested with some very big companies, and it was a fairly challenging project because it's a safety critical device. What HydraTune does is it basically eliminates the service technician having to adjust a hydraulic valve. Usually it's like a pilot screw, reaching into an area that might be running on a machine, having to adjust that in a very sensitive way. If something was to go wrong with the hydraulics and high pressure hydraulic fluid was to spray out, if you're in the vicinity, that can basically come through your protective clothing and into your skin. And once it gets into your skin, it can cause you to
in trouble.
So, having a safety critical IoT device that is controlled via a tablet via Bluetooth, challenging. And also the environment that the device is going into is challenging. You've got a steel structure of the machine, usually big cast iron machines with sort of sheet metal plated or covers around everything. You've got to have very good RF performance. For us, we knew it could be done. We've got our Cranio system, which is the core of it, the firmware, the Bluetooth communications, the app, the core of the app is our Cranio system. But implementing that in a way that is robust over tens of meters to a rugged tablet means that you basically need a big antenna. It needs to go onto this box. Effectively, you've got a removable battery, so you can change batteries in and out, and you've got a stepper motor controller with a Bluetooth antenna and a pressure, 4 to 20 milliamp pressure sensor. That could be a plastic injection molded box that goes together. It could be a sexy looking thing like a Milwaukee, whatever, but we're not talking about tens of thousands or hundreds of thousands of devices. Also, you're in a rugged environment with people who are, going to be rough with this thing. Shane was really keen on CNC machined aluminium and anodized sort of look. So we, first of all, went down the industrial design path to form, fit and function as best as possibly could. He chose one of the more extreme forms that we had. So we came up with some different designs in Blender, and Nicole did an awesome job of that. But through that process, Nicole was always working with Min, I think it was, basically getting something that was looked and felt and did the right job. Then Min had the challenge of making it manufacturable. But I think the manufacturability part was kind of made easier by the fact that he was consulting with Nicole.
That was known from the start.
Yeah,
basically.
from the very
this
start.
is what we're doing.
Yep. And again, it's not rocket science, but it's got to be all pulled together.
It is important, right?
Yeah,
because that design is very different potentially to what it would have been if it was injection molded or something.
Yeah, exactly. Yeah. So if it's going to be injection molded, it's going to be different. It's going to have draft angles. Yeah. It's going to have to be thin. The product was designed around the manufacturing processes which we wanted to have, which were basically designed around the volumes that we're going to be having in the field. It was a great project. I mean, it encompassed all of our skills here at Element, and it even took into account our Cranio ecosystem, which obviously got HydraTune to market much faster. Then there's a licensing agreement that comes off the back of that for the use of it, which as part of paying for that licensing agreement, they get access to all the updates that we have with the Cranio system, making it better, over-the-air firmware updates, improvements, security patches, things like that, which are the things that we've always struggled to do individually for each customer. The other part as well, we did all of the manufacturing, all the prototyping here in-house. It was probably one of the first. There's a couple of other projects which we've done. We used to offshore a lot of it to China. We had very good suppliers in China. Haven't had much success in getting the interesting, very complex, a lot of the time complex things that we do done locally, unfortunately. And we made a decision back in 2020 when COVID pretty much stopped everything to basically have our own machines in-house. So we knew the manufacturing processes we've got here. We said to the customer, in no way are they bound to us doing the manufacturing. We're going to make sure that the manufacturing packages and everything can be used anywhere in the world. But optionally, we'd given them the option to manufacture with us, and we have been successful in doing the first batch of tens of devices, which has been amazing.
Yeah.
So hopefully we can make sure our pencil's sharp and our manufacturing is good for the next batches.
It was quite collaborative too, right?
Yeah, very collaborative.
Again, if you didn't do that, you might go down the wrong path, or just then they might not be happy, right?
Yeah. At the end of the day, HydraTune is a product that needs to stand on its own, and we want it to be as saleable as possible. You had a lot to do with the manufacturing designs and mechanical designs and electronics integration and all the drawing packages. That's a big project.
It was obviously quite collaborative. Min worked well with. I mean, all our teams gel well together anyway. I think that's just one of the advantages we have.
Oh, that's something that we've set up for the business. Over time.
For a reason.
Yeah. Making sure that the mechanical team sits next to the electronics team. The workshop guy is in the mechanical pod. The firmware guys work super closely with the electronics guys because they're designing the electronics around what the firmware is capable of, or what the firmware challenges are. The web team is always interfacing with the firmware team because the flow of data. And industrial design is always working directly with mechanical.
Yeah, so basically everything's aimed at
you've got a sort of a circular motion, and sometimes they do cross over, but you've basically got different pieces of the puzzle you have to bring together, and that's why we have everyone in the same office. A lot of people like to work from the office because you can just literally get up and talk to the guy next to you.
Everything is faster, right? You can do everything faster.
Yeah.
So even with the HydraTune one, I know when we're going through, and we got it pretty close, I think, from you know, some of the first designs that we had, again, because of that collaboration between Min and Nicole at the time. I think that the changes that were made through the first few prototypes were quite minimal, really.
Yeah.
Mechanical engineers would work with our machinist. The feedback was kind of direct.
Yeah.
We'd spit one out. Hey guys, you want to come and have a look at it?
Yep.
Yeah, cool. We'd quickly assemble it. Oh, there's a few tweaks we can make to the seals here or whatever. Everything becomes more fluid.
Yeah.
Again,
if you're going to do that in another business, just making sure that you've got the supplier close to you, or you can go into the supplier. One-on-one in-person conversation is just number one. You know, being able to actually see what their body language is when they're looking at that drawing and going like, oh, geez. You don't get that over Teams. Yeah. You definitely don't get that over email. Yeah. You just get the off price. So we're currently working on our upcoming own data logging and control system, Cranio. A major part of the system are the mechanical Pro-IO devices. We're CNC machining the housings, injection molding LSR seals for these right now. Workshop, Cranio, my pet project. Pet project that Dan has supported me and the business on. Let me go and learn how to do production grade electronics and IoT, and Dan's basically run the business in the meantime while I go do those things, which have resulted in us doing cool IoT things. The Cranio Pro-IO system is an interesting one. It fulfills a niche which is really, really rugged embedded devices that don't need a control cabinet, so to speak. So, you know, a lot of the time when you're going to make something that's going to be put remotely out there, you might need you get a pole, you put a control cabinet, you have glands and seals and electronic widgets inside the control cabinet. You might have a SCADA system with wiring and things like that. I wanted to make it more simple than that. The Pro-IO system is basically trying to simplify that assembly process, making it so the system can be configurable as well. So you've got any sort of communication you want with the IoT device. So you've got cellular, Wi-Fi, long-range RF, and Bluetooth for configuration. And then having different I/O. So you've got analog sensors, digital sensors, analog outputs, digital outputs. You can run relays and stepper motors and things like that. The Pro-IO system is really made to be kind of easily put on a pole out in a field with a solar panel. Cables from your sensors and actuators basically come through these liquid silicon rubber glands, and you don't have to have special cable terminating ends. One of my pet peeves is, you know, doing things on mine sites is using special connectors. Deutsch connectors and things like that have become quite standardized these days, but back in the day you'd have to buy a $700 set of crimpers. You'd have to then prepare the right size cable. You'd have to make sure you've got all the right seals. You have to be, you know, a technician, right? We wanted to make it simple for any technically capable person to be able to do IoT, and Pro-IO does it in a rugged environment. So CNC'd aluminium housings, they're basically so that you can be rough and tumble. The plastic top is because it needs to get the Bluetooth communications in and out. It's still going to be rugged. It's stackable, so you can add different bits and pieces in. And that was the dream that I had, that we're slowly getting there, hopefully getting this thing out to market very soon. But the manufacturing processes that I've chosen for it are basically dictated by the volumes that we want to get. We want to get a couple of thousand of these out to the world. We want to get into some really rugged and harsh environments for mining and oil and gas in particular. Liquid silicon rubber flaps and buttons and the seals, they're a challenge. I did liquid silicon rubber design. They have to be designed with precision. They have to be manufactured with precision. They are also super advantageous. Instead of, you know, that button, for instance, if you just use the underlying electronic button piece and then use that liquid silicon rubber button cover, it might be a few cents in volume. To buy someone else's button off the shelf, which has a seal in it that has the same seal rating as this, could be dollars of BOM cost, if not a few dollars, you know. And it could be bulky and has special wiring connectors and all type of stuff. You can't surface mount it. So the liquid silicon rubber pieces were a choice that I made to make the product better, but also to make the user's end use better as well. Because there's Jiffy boxes with different sealed pressed buttons and LEDs coming through. They work fine, but when someone's paying good money for a ruggedized industrial device that they want to go, you know, put in the desert and it's going to give them critical information that they don't currently have, you want it to look good and feel good too. So that was a compromise, so to speak. It's something that we're doing internally, which is a passion project, which then gives us these skills to be able to utilize for our customers, and teaches us how to become a manufacturing supplier and do these things with high precision and quality. And we can basically take the risk in our own product.
Yeah.
So it's been a pretty good process so far. How have your guys found it? Doing all the mechanical parts of it?
We've got a couple of our mech guys kind of dedicated to it over time, and it's always, again, been for them a really good experience, learning experience. It's cool, also nice to be part of something that's, I guess, at the forefront, or just with the tech behind it.
Yeah.
Rather than sometimes the mech team just doing steel stuff. It's nice to for us the change of pace is kind of nice as well.
Yeah. IoT is a really hard place to play, because you have to have that whole integration: mechanical, electronics, firmware, some sort of software to be able to get the data on and off. Industrial design, because it's got to look pretty and it's got to do its job. It takes all of these different skills, and one of the reasons why we've brought it in-house is because it teaches us a lot. And we can then use those learnings to basically make sure that we're a better company for our customers. Hopefully this thing becomes an actual product, which we're confident that it will. It needs a few more big pieces of the puzzle, like the front end system needs to be really, really easy to use to be able to interface with that data. It needs to be seamless with the setup. We have to commit and deliver on the promise of easy setup. That's a really hard thing to do. If you're having to log into the thing and use Linux commands or whatever, you're kind of in the same realm as the Arduinos and the Raspberry Pis and those sorts of things, which we want to go one step further. We want to make it really easy. But, designing all these pieces of the puzzle together for IoT is really hard. Smart machines is the same as well. You might have a machine that was previously mechanically driven, and now you want to put some sensors on it and a PLC or SCADA system on it. There's another level of complexity and integration, teams talking to each other, new people having, electronics or the control system having a bearing on what that mechanical widget might do. So I guess communication is the main thing, and making sure that everyone is on the same page. And it's probably not just communication, but good use of communication or efficient communication. That's probably how you can, get the good. Where is it? Get the good. Get
good box on the
tick
triangle.
Good, tick fast, and tick cost. And I think cost is the hardest one when you're talking about good and fast production. I think to be able to have good and fast, and low cost, you probably have to have experience.
Because you're always balancing all three, right? To some degree.
Yeah, exactly. Yeah, that's why the engineering triangles here. Yeah. But yeah, DFM, design for manufacture, is an art. Well, it's a science, but it also comes with experience. So I guess you could call it an art.
Yeah.
But having people you can lean on and trust and have really in-depth conversations with as to what their pain points are is probably the main key to design for manufacture in my experience. That's all for today. Thanks to everyone for listening in. Feel free to like, subscribe, and leave a review. Have your say. Hot takes are very welcome. Until next time, make it good, make it fast. See you soon.
See you guys.